The iJaw is the world's first sensorized clamping jaw. It allows you to measure and visualize clamping forces during machining in real time. With the iJaw, you achieve higher productivity, lower costs, and greater safety. We call that smarter clamping. And now, the iJaw brings automated processing to your workpieces as well. The roundness of raw material is defined in DIN EN 10060. According to this standard, radial out of roundness of up to 2 millimeters is permissible. If such a blank is misaligned during clamping, it can cause severe imbalance during machining. This is exactly where the iJaw comes into play, taking over the role of an experienced machine operator. It measures the actual clamping force acting on the workpiece and detects whether it is distributed symmetrically. This makes it possible to reliably identify eccentric clamping. Based on the iJaw's feedback, robots can then realign the part if necessary. The result: only safely clamped workpieces are released for machining. In addition, with every loading and unloading cycle, the dimensions of the gripping surfaces of the machined workpiece are measured. This enables continuous quality monitoring and allows deviations in the finished part to be detected at an early stage. During loading and unloading, the iJaw sensor, the stroke sensor on the gripper, the IO-Link wireless master, and the machine control system work together as an integrated unit. Together, they form the core elements of this smarter clamping application. The very first diameter check is already performed during the gripping process by the stroke sensor on the gripper with an accuracy of ±5 mu. If the workpiece lies within the predefined tolerances, it is inserted into the chuck and clamped. Now the iJaw sensor takes over, measuring both the clamping force and the eccentricity. If both checks are successful, the iJaw sends the release signal to the cobot. In turn, the cobot transmits the corresponding signal to the machine control system, releasing the start of machining. However, there are situations where workpieces are clamped eccentrically, causing considerable imbalance and preventing safe, high-quality machining. The smarter clamping application shown here is capable of detecting eccentrically clamped workpieces and performing their realignment. To achieve this, the TIGO gateway continuously receives and processes data from the iJaw and the cobot sensors, issuing the corresponding commands to the machine control for clamping and unclamping. If necessary, the workpiece is realigned and reclamped multiple times until an ideal concentric position is reached. Afterwards, the cobot releases the workpiece for machining. This smarter clamping application is also capable of sorting out damaged workpieces, or those outside the defined tolerances, either before or immediately after machining. As a result, balancing quality is significantly improved and machine service life is extended, for example, through reduced load on the main spindle bearings. The sorting of extremely out-of-round blanks can take place as early as the gripping process or after several unsuccessful clamping attempts without achieving concentric alignment. Critical functional features of finished parts can be measured directly during unloading, all in a single step, with no loss of time or additional effort. For example, finished parts can be sorted into tolerance classes. In this way, this smarter clamping application makes a unique contribution to optimizing the technological steps, loading, machining, and inspection. The presented smarter clamping application delivers the following benefits: enhanced machining quality and precision through concentric clamping with the required clamping force, lower workpiece rejection rates by preventing severe imbalance and continuously monitoring clamping forces, higher productivity and cost efficiency thanks to integrated measurement capabilities, seamless, flexible, and cost-effective integration into existing production environments. For more information, visit our product page at ijaw.de